YouTube complained, oh, your video is shaking, do you want to reprocess? And I said, no.
You said it was alkenes and radicals.
This is called haloalkanes or alkyl halides. And these alkyl halides are those that have halogens on it, yes? Now, these alkyl halides are used for many things. You already know a few reactions in which you synthesize alkyl halides, right? Like addition, hydrohalogenation, yes? Or bromination. We're going to do something that is radical now. There are two types of bond cleavage. I don't even know if I spelled that correctly. Cleavage, is that how you spell it? Like cleavage on a...
Yes.
There is
heterolytic,
and
and homolytic.
homolytic. What's wrong with this girl?
Chairs.
She can sit. And homolytic. Now homo means what?
Same.
Same, outstanding. So same what? When I am talking about bond cleavage or breaking a bond, the homo means same. Each of the elements that are broken keeps an electron. So from two bonds, one of the elements keep one electron and the other element keeps the other electron. Heterolytic means they're different, yes?
Yeah.
So one keeps all the electrons while the other one keeps none of the electrons.
And that's what we've been doing, right?
Yes, that's what we have been doing so far. So here's A and B. In heterolytic bond cleavage, you have something like this. And when this something like that happens, what you get is A plus, because all the electrons went with B. And then you have B minus. That is heterolytic. Homolytic bond cleavage, it's like this. This one here goes to that element, and the other one goes to the other element. Those arrows are different. These are double-headed arrows, and these are
Single-headed.
single-headed. And I explained to you before, and I tell my 1025 students, nobody in here has been my 1025 student? Only 1046? Shame on you. I have told you many times before, one head means one electron, and then two-headed arrows means two electrons, okay? So what happens here is A keeps one electron while B keeps the other electrons. Those are called radicals, okay? It's not a negative charge, it's not a positive charge, it is neutral. Did we name alkyl halides before? We named these, yes, and we don't have to name them again? Like it's just a regular alkane with a chlorine or a bromine on it. We're not going to name those again, okay? Yeah, let's talk about physical properties. Physical properties like these are boiling point. Tell me, how is a boiling point for those? Which one is a higher boiling point?
One on the right.
Iodine.
The I is a higher boiling point? Why is the I the high boiling point? Yes, remember there are two things, yes? there is molecular weight and then there is bond polarity, dipole moment, yes? Now this is more polar than that is. So this feels more dipole-dipole forces, right? But this feels bigger London dispersion forces. As a result, this one has a higher boiling point. So no matter what type of element or what type of chain you have, most of the time the one that has the iodine has the higher boiling point because of an increase in what? London dispersion forces. Did you learn that in 1045?
1046.
Oh, you learned that in 1046. With probably a good professor, didn't you?
The most excellent professor.
That's very nice. You got 5 points extra. All right. So here is, we're going to do this reaction next. Here is methane. And we are going to treat that methane with Cl2. Does that look like something we have done before? Yes, but before it was addition to a double bond, yes?
Yes.
And this time, we are going to do this reaction in the presence of light. That's what that is.
Oh.
Now, if you do not have light or you do not have heat, and most of the time it's about 300, 350 degrees Celsius. If you do not have heat, the reaction will not occur. The reason for that is because radicals are not going to be made. Now, if there is light, radicals are formed. And what you have is, tell me what happened.
One of the hydrogens.
Huh? What happened?
One of the
One of the
Hydrogens
hydrogens
left.
was replaced by the Cl. Outstanding. So here we're going to have the other Cl, and one of the hydrogens made HCl. Now this is, how many halogens does this have?
One.
So this is called monochlorinated. The reason why I tell you this is monochlorinated is because on the test I'm going to ask you, provide monohalogenated products, or maybe I tell you provide dihalogenated products. Now, after you form this first one, there is no reason why this one cannot react with whatever else is left there. Yes? And what is it going to form this time? So this time it is going to form dichlorinated. And if it does it again, what is it going to form? Trichlorinated. And if it does it again, what is it going to form? Okay. Yeah, tetra. Mono, di, tri, tetra. Now you can kind of manipulate this. In general, what you have is a mixture of them. Okay? Since you have a mixture of them, I am never going to ask you to give me all, unless the question is specifically, give me all of the chlorinated products. In general, I'm going to ask you for monochlorinated, but you have to know that what else do you form? You form
tri,
and tri, and tetra. That's in that case. And sometimes you can have more than 3 or 4 or 5.
And all you have to do is just repeat the process.
What happened?
All you have to do is just keep repeating the process.
Yes. Okay, you know, let's talk about you want to do that mechanism already, or you want to wait a little until you guys are
Yeah, take this as
what's that thing that is sound?
It's mixed one.
Smidge foam? That's the foam that is acting up, or this one here?
That's the point.
Because if it's this one here, I'm gonna spit on it until it's... Smidge's foam?
Yeah.
That's a picture of a naked guy on it. All right.
What did you say?
So, okay. So let's say this is called mechanism for radical halogenation. Now this mechanism is a lot of fun, okay? Mechanism is composed of 3 steps. The first step is going to be called initiation. Okay? In the initiation step, radicals are made. Should we say made or formed?
Formed.
You like formed better?
Yeah.
You guys are so professional. Now these radicals are formed, and most of the time these radicals will be formed from here. Now carbon-hydrogen radicals or carbon-carbon radicals take a lot of energy to form, but these don't take that much energy. So under given conditions of light or heat, which radicals are going to get formed first?
The ones that-
Chlorine radicals, okay? Now what happens is, what happened? What was that called? Homolytic bond cleavage. Have homolytic bond cleavage. And you are going to form 2 Cl radicals. Okay? The next step is called propagation. And what do you think happens in the propagation step? Radicals react with things that are not radicals to form more radicals. And then more radicals are formed because you form more radicals and more radicals and more radicals. Radical is going to get formed is this one. We have the simplest of all cases, methane. Do you think I'm going to give you a mechanism on the test that is this simple?
No.
With methane? Probably not. Unless I'm in a good mood because I got 1,000 hits on this video. From this class only. Right? But I can see it, okay? I can see how many minutes you watch it, okay? You can't lie. You cannot lie to me. I'm not your boyfriend. All right. So here's what happens. There is a bond, yes?
Yep.
And there is a radical. Now the radical wants to abstract a hydrogen from this methane. The electron from this bond is going to make this electron from this, and this other electron is going to make a bond that is composed of how many electrons?
2.
2 electrons. The rest of the electrons from that bond are going to go to that carbon. Yes?
Yep.
Which is just that
So-
one.
Which is what?
One.
Yeah, step 1. You want to call it step 1? Like the next one is going to be 2?
No, that's not what I'm asking. You said that that one little electron goes towards the H, and then the rest of the electrons go towards the carbon, and being one, right?
Yeah, 1 electron, yeah. 1 goes to make that bond, and 1 goes to this. Yeah, 2 electrons. And what this is going to form is the carbon radical. And what else?
HCl.
HCl. With 1 electron coming from the chlorine and the other electron coming from
The hydrogen.
the carbon-hydrogen bond. Okay, now this radical, so in this step, you have a radical reacting to form
Another radical. Yeah.
Okay? Now, okay, let's put it, let's continue there since I have enough board space. Now, what's gonna happen is, there are CLs all over the place. Some of which have not are still intact. They have not, how do you say it, broken?
Yeah. No.
Have not breaking?
Broken. They've not broken.
But that's in the past, how do you say break now? So, here it is. What is it going to do? Exactly what the chlorine did here is going to happen here. This radical is going to go to that chlorine and like that. The chlorine is going to use an electron from this bond Now, what did that generate?
The chlorine radical.
That regenerated another chlorine radical. And what did that chlorine radical go do? It went to do this step. And then this step did what again? Generated this.
Yeah.
Which did that to the Cl, which did this and generated another chlorine radical, and then continue going on for a very long time. Continuation of the radicals. Okay? So this is why this is called propagation. So you don't like watching the videos, do you? Why not? Because you do not have patience to sit, huh? Now, in the last step, this is called chain termination, yes? This is called chain initiation. This is called chain propagation, and this is called chain termination. So, in the first step, in initiation, radicals are formed. In the second step, more radicals are formed, and you have product. And on the third step, what you have is termination of those radicals. In the termination of radicals, guess what happens? Radicals
Terminate.
Radicals die, yes? They do die. Okay, so radicals combine to form things that are not radical anymore, right? Give me an example of two radicals combined. Hello? Cl radical, outstanding. There it is. Cl radical with what? With another Cl radical. Why not? There's Mitch's phone, man. And this is forming what did that do to those two radicals? Terminated them. No
terminate.
more radicals.
Okay.
What else?
Bromine, right?
Bromine. What in the world? What do you mean bromine? Where's the bromine at? I don't see any bromines
Is there
there.
any other one? You said halogen, so bromine.
You say it says
Well,
halogen.
you can use bromine too, right?
I'm talking about what we're doing here.
Okay.
No bromine here.
So,
Yeah, bromine if there was bromine, but there's no bromine. Okay, you trip.
the hydrogen carbon bond?
The hydrogen carbon bond. Tell me the radical. Which radical?
See?
Carbon
Carbon radical. Yeah.
That's what I know. That's what you meant, but combining with what?
With another,
With another carbon
radical.
Outstanding. See, you guys don't need me for anything. Why don't you just go home and study this on your own? So, there's what it is. And what is this going to produce?
It's going to a termination.
Yeah, it's chain
what?
termination, but what is it going to make?
CH4.
Yeah,
Ethane, yes?
Ethane. Yeah.
Ethane, ethane, yeah, this is not English, don't worry. You're not going to be penalized for anything like that.
So that's where you're bringing them together. At the termination stage.
Yes, you're bringing them together. What else can I have? I can have another one in which this radical does what? It already combined with another carbon radical. The chlorine combined with another chlorine radical. Now what?
Can combine
Chlor-
with
the chlorine radical?
This carbon is going to combine with this radical. There it is. And this is going to produce don't tell me you can't do this mechanism on the test, right?
That's right.
You can do it. Believe me, you can. If not, you will
Just
pay.
skip it.
Yeah.
How long are you gonna take to do this mechanism? Practice it until you do it in less than 1 minute. That's what I want from you.
Okay.
Anything else is a failure on both of our parts. 2 minutes? No. Less than 1 minute.
Is that OH?
Excuse me?
Oh, no, it's an arrow.
Oh, H.
Because it looks like an ulcer.
Which one looks like an O?
The one that's right next to the H.
Where?
Over there, the last, like the arrow. Like it yields, but it yields for oil.
This one? Is an
No,
O?
the arrow. The wannabe arrow.
It does.
Right next to the H.
It looks like a H.
This?
Yeah.
Yes.
Looks like a.
Outstanding.
Okay, good. Some of you will tell me, oh, what's that triangle? Okay. Now, the reaction with F2, the same radical reaction with F2 should provide what? The fluorinated alkanes. The reaction with F2 is very fast, is very exothermic, even explosive, so not good. Okay? So we will never have a reaction because fluorine is too reactive. Did you write that down?
Also, iodine, iodine is too slow, right?
Exactly.
So it's too. Fluorine is too reactive.
Okay? So next in speed is chlorine. We can handle it. Then how about bromine? It's slower, and I2, too slow. So this one is too slow, not reactive. And this one is too fast, too reactive. Okay? So the only ones that we are going to use in this class are Cl2 and Br2. I am going to tell you first, and this is kind of incorrect to tell you this way, but I'm going to say it like this. The chlorine radical is not very selective, okay? Chlorine radicals are not very selective, while bromine radicals are very selective. And that means that they select what hydrogen to pull. What happened?
Does everything to be mechanical?
No. Everything to you is now Marconi.
You said chlorine is selective?
Uh-huh.
Chlorine's not.
I said chlorine is not too selective, and bromine is
Very
like
selective.
more selective, or selective. Okay, and the reason for that is energy differences in the transition state. Okay? Now, what I'm going to tell you is, for chlorine, for the reaction of chlorine, I'm going to give you ratios of the selectivity. And the ratios are like this. Let's do first tertiary, secondary, primary hydrogens. We do know what they are, yes? Primary, secondary,
Of course,
tertiary?
yes.
I bet some of you don't. The ratio is 5 to 3.5 to 1. Which one does it like more, this chlorine? The tertiary, about 5 times compared to the rest of the stuff. 5 times more compared to what? Primary. And 3.5 times more compared to secondary compared to primary. Okay? That is for Cl2. For Br2, because it's more selective, right? This is tertiary, secondary, primary. This is about 1,600 times more. Secondary is about 800 times, and this is about 1 time. So how selective is bromine?
Very.
Very selective, yes?
Yes.
If you were selective like that, you would have never had a girlfriend. Yes? That's why you're supposed to. Okay, so here's how we are going to use this. From here, you've got to memorize those numbers for the test. I think they're easy, yes? Okay, this is like twice this amount, yes? And that's 1. And here, these numbers are 5, 3. I don't know how you're going to do it, but memorize it. Question on the test I'm going to ask you. I'm going to give you a structure. And I'm going to ask you to predict the percent of monochlorinated products. Okay? Hello? So, let's say I give you this structure. Let's say I give you that structure. And I ask you to predict the percent of all monochlorinated products. Started class late today, huh? So you guys did get here on time. I waited for you, then I left. So, here's how you do this. How many, you count the number of hydrogens you have of a certain type, and you multiply it by the number it belongs to. Yes or no? How many primary hydrogens do I have? Damn, it's difficult, huh? Not really want to speak then. 9? 20? Is this primary or secondary? I told you guys forgot.
That's secondary.
This is primary.
Primary, yeah.
But you said
This card.
you said hydrogens.
Yeah, hydrogens.
What do you mean?
You said primary.
Guys, of course, primary hydrogens. Hydrogens only make, these hydrogens are primary because they're on a carbon that is primary. Yes?
Yeah.
Okay, well, you didn't understand that, okay, now you do. How many hydrogens are on primary carbons, if you want to be that specific?
9.
11.
There's 3 here, yes?
Yes.
1 bond. There is 3 here, 1 bond to this carbon. There is another 3 there, 1 bond to this. They're all primary. So that's 3, 5, and 9, yes?
9, okay.
So that is 9 primary hydrogens, yes or no? You agree?
Yes.
9 primary hydrogens. I am going to multiply this by the number that is for primary. Which one is it?
1.
Times 1, and this will give me
9.
9. Very nice. I think this is like differential equations of multivariable calculus, yes? Something like that. What's next? Secondary carbons. How many hydrogens are secondary?
3.5. Oh, I'm sorry.
This carbon here has one carbon there and another carbon here, so that's 2. Times, what's the number for secondary?
3.5.
3.5.
3.5. Explain to me how much that is.
7.
Alright, very nice. I'm going to do it now for tertiary. How many tertiaries? 1. This carbon here is tertiary, and the carbon on it, and the hydrogen on it is, as a result, tertiary. And that's going to be 1 bond, 2 bonds, 3 bonds. 1, what is the number? 5. I will multiply this times 5. And that is the numbers you get. I add them together. How much is this? 5 plus 7 plus 9.
21.
What's the number? Sophia, why aren't you talking?
Apparently, my question doesn't allow people to concentrate. My questions or my comments, so we're still
Really?
quiet.
Since when? Who told you that? I said that to you? Who said it? He said it. Look, he's escaping.
21.
Damn, busted.
Sophia, don't get offended. It's not personal. Maria and Sophia are not speaking today because they don't want their words on video, yes?
Sure.
Okay, so this is 21. Yes or no?
Yep.
Sophia, you agree?
Yes, I concur.
So what you are going to do now, this is the total, and you are going to divide the part by the total. Yes? So I divide 9 by 21 and multiply this times 100. What does that give you? Sophia, what does it give you?
I don't know.
Am I funny looking in the back or something?
That's too much math.
Guys, put this stuff in your calculator. Put it in your phone. How much? 42.9%?
Yeah.
You sure?
42.86.
Now, let's call it 43%. How about that?
Where are you
Yeah,
rounding?
43.
Where am I rounding?
Second digit, first digit?
Yeah, it's 43.
43%.
Yeah.
7 divided by 21 is how much?
33.
Times 100, this is 33%. And 5 divided by 21 is?
24.
How much?
24.
So tell me. This monochlorinated product is going to be what percent? Maria? Huh? You don't know? How much is it? This is a tertiary.
Yeah.
Tertiary. Is this tertiary?
Uh-huh.
24%. Mitch, she said that in your phone there was a naked guy coming out, man. She said, she saw it, yeah. 24%. And the other one for the primary could be here, or where else could it be? Or here. They're different products. And we're gonna put them together. We're gonna say that this one and this one plus this one both both of these are how much? Those are primary, yes? Both of those are how much? 43%. And the other one is secondary, which is how much is this one? 33%. Okay? How do you like that?
Do you want us to separate them like that on the exam?
Yeah. What do you mean separate them? You did not separate them, you just gave me the product and their percentages. Yeah.
How did you get this 5 from the picture?
How did you get the 5 from the what?
Tertiary.
That's the
From
ratio.
the
That's the
ratio up
ratio on
there.
top.
You mean this 5? You mean this 5?
Yes.
Or this 5?
No,
This one?
Yes.
From here.
Oh,
This is what you guys gotta memorize. 5 is for tertiary, 3.5 is for secondary, and 1 is for primary. I mean, and some books have different numbers, okay, but slightly different, so who cares?
How come, for the 43%, how come you didn't do it with the CH3 on the left? Is that not included, or?
Yeah, but the CH3 on the top and the CH3 on the side left is the same CH3.
Okay, so it doesn't matter.
It doesn't matter, yeah. The one that is very different is that one on that side. That is next to a CH2. Yes? What else?
Bless you.
Sophia, if you don't start talking, I'm gonna sit you right here on top of this table.
Okay.
Okay, why don't you calculate the same for this same thing, but now this time for bromine.
The one that you read, was it exactly one of those, just one?
It wasn't one of those.
Oh,
You-
we didn't write it down yet.
You did not write it down?
I was just about to start.
Don't worry, that's what I'm here for. I'll be here all week. Which is ending today. It wasn't precisely written like that, but it is the same thing.
Yeah, would it be mono?
Would it be monobrominated?
Yeah, monobrominated products only. Because you can have di and tri. Yes, I don't want you to do calculation for di and tri, only mono.
So for that same one,
For the,
Yes, for the same one, Sophia. Thank you for asking. Maria, you sure you don't have a question?
it'll be selfish for me to ask questions when other people get studied too.
Really?
So I'm gonna take one for the team. Just for today.
Oh, just for today? Okay, all right. I can take that.
Take one for the team.
Yes, you do.
I'm lost as to how you came up with the chlorine attached to CH3 attached to carbon and then you told me how do you pull stuff like that?
I did not pull stuff from anywhere. You put the chlorine where there is a hydrogen.
You just killed your own.
And those are the different options where you can put that chlorine and replace it with a hydrogen.
That's why you use it's primary as well.
Also, you're only doing the chlorine. That's all you care about?
Tomorrow I have to go to that.
It's missing
It tells tells you the percent of the product.
I mean,
Like if you,
that much chlorine and primary
yeah,
probably.
no, that's the number you get. If you run the experiment, if you mix this stuff together, that's the percent you get of each one. So if you wanted to make this one, let's say, with a chlorine here, that's what you would make, 24%. You just gotta separate it, but you have 24%.
Is there a reason why you split?
Is there a reason why I split it? Split what?
Like how you did it in addition, the chlorine and chlorine did it in addition.
Here?
Yeah. Like you're adding it.
Yeah. This here is primary, yes? Okay, let's look at this one here. This one here is primary, yes? Is this one here primary?
Yes.
And is this one here primary?
Yes.
So I replace, I take one of these hydrogens out and I put a chlorine. That's the one on the top. I did not show you this here because the CH3 there and this CH3 here is the same. It's still on the CH3 that has this carbon with another CH3. And this one's still primary, but it's different primary as if I put the chlorine here or here. So I gave you one in which it's here, which is this one. Yes? And this one doesn't have the chlorines. This one has it, that one doesn't. And I put, because both of these are at primary, and I did not separate them here, then I tell you both of these together, because they're primary, is 43%. So if you were to run this reaction, you mix this stuff in a flask, and you do this reaction, that's the percent that you would get of each. Yes?
Going back to like what you were saying before, about the selective and the not so selective. You said that the reason why is because of energy what?
Energy differences in the transition state. This is called Hammonds postulate. Guys, you did it already?
Yes.
Okay. So we're doing the same thing, but instead of monochlorinated, it will be for monobrominated. Yes. So what we are going to do is we're going to find tertiary, secondary, and primary. You multiply the number of hydrogens times the ratio. Outstanding. So how many tertiary hydrogens did I find? One. I am going to multiply this times 1600, and it's going to give you 1600. How many secondary hydrogens did I have? I had 2. I'm going to multiply this times 800. What is this going to give?
1600.
1600. I am going to multiply how many for primary? 9 times. Oh, what is this? Not looking good for primary, huh?
3209.
So what do? You add all of them together. What do you get?
3209.
Who?
3209.
3,200.
And what you do is you get this number and divide by the total.
49.9%.
49 point.
9.9.
So let's say 50. And we say, okay, whatever, 49.9%. And then 16 divided by 3209 times 100, how much does that give you?
More than there.
Oh, same number divided by the same number, it's the same number. And then is 9 divided by
Which gives me 0.28.
0.28.
C. Percent.
If you add all of these numbers, does it give you 100%?
It's more than
What's that calculation you made here?
That's what the thing said. I had to round to six.
That's 49.8.
It's 1025, sir. Yeah, but that's actually not. It's not correct, so there's something wrong.
I don't know, you messed things up.
I don't know, maybe your ratios are wrong or something.
Really? It doesn't matter. I could put here whatever ratio I want.
So maybe just.
When you add the numbers together, the total is a total, yes? And if you divide, it's supposed to give you 100, no matter what numbers you use. So even if I am incorrect, you should still add up to 100.
I don't know.
49.86. It's 49.86.
Yeah, that's 49.86.
49.86?
The second one, yeah.
Okay, guys, you know what? It doesn't. Okay, you want to try another one?
And the first one is 49.8.
Guys, whatever, okay? Doesn't matter. We're not gonna get into the little details here of, oh my God, there's 0.1 here, 0.1 there, 83. Let's do another one. How about that?
Oh my God.
Where's the video again? Rewind.
Oh, we're not finished? That's what you mean to say? All right, let's do them. Which one do you want to do first? Tertiary, secondary, primary? It does matter. Look, let's do tertiary first. So what do? I get the tertiary, I raise it, and I put that there.
BR.
Oh, it's a BR?
Yeah.
And
That's it.
what's the percentage for this?
49.9.
Let's say 49%. Which one is the other one? I rewrite the same thing, right? CH2, CH3. Now, a CH3 and a CH3 here makes very little difference, yes? So I am only going to change one of those. I am not going to change them both because there's the same structure. So what do you want to do? Take one from here, CH2, and put a Cl.
BR.
Oh, it's a BR. Well, at least you're paying that much attention. How much is that? I don't know. I don't know, because this is not the only primary I have, yes? I have this other primary. Which other primary do I have?
This CH3 on this one on the left.
On the
This
left,
CH3 here.
and
Yeah,
on the right.
on the right.
Yeah, but we already agreed that this one and this one were the
Oh,
same.
okay.
Yeah. Okay, the one on
So
the right.
CH2, now these two are primary, and the primary is 0.28. Like, let's say 0.3%. What are you covering in your mouth? Scared?
No.
And which one is the other one? The other one is a secondary. Here's tertiary, here's secondary. You take one out and put a chlorine there. How much is this one? 49 plus 49 plus 0.3 gives you 100%, right? Close?
Yeah.
Not 100%, but oh, wouldn't it be BR? Okay? Yes or no? Is that good? We don't need to try another one, do we? Guys?
No.
Sophia, do you want another one?
No, I'm good, thank you.
How about you?